welcome to another wonderful lesson in our Python developer course. This particular lesson is our lesson 18. As a matter of fact, the 18th topic in Python we are learning, and it's going to be a series. And so we'll be treating part 1 today, and next week we'll tackle part 2 and probably part 3 and part 4. It's a very, very powerful topic in Python that will help us analyze data and understand data management in Python. Before we get into it, I want to give a very, very short motivational message, as I always do. And it says that a river cuts through rock, not because of its power, but because of its persistence. Because of its persistence. A river cuts through rock, not because of its power, but because of its persistence. That persistence is very powerful. That consistency is very powerful. That determination is very powerful. And that is where your success lies. All right. So understanding big concepts and skills in tech is not about having a powerful lesson one day. It's about consistently getting yourself close to the concept and the lesson and the skill. It's about repeating. It's about being persistent and being with that skill for a while. And with time, you will realize that you get it. I keep saying that there are certain topics in IT that when you hear about them for the first time, they sound so technical, they sound so difficult, but it is because you have not gotten into it. All right. Sometimes the terminologies we use to name them, they sound so advanced. Like you hear things like deep learning, like neural networks, convolutional neural networks. You start hearing advanced things. It sounds so complicated to you, and sometimes you feel like you are not there or this is for other people. It will always seem like that until you get yourself into it. And as you get yourself into it, little by little, with persistence, you will break through. So in machine learning, you will break through. In data analytics, you will break through. In cybersecurity, advanced cybersecurity, you will break through. Just get yourself close to it consistently, persistently, you will break through. In cloud and DevOps, you will break through. In software engineering, all the top concept React and React Native and all the MongoDBs and all the advanced topics, you are going to know them. You just need to get yourself into them consistently and you will break through. Every specialist today, every expert today was once a beginner. Today, you may be a beginner, but with this persistence, tomorrow you are going to be a leader. You are going to be a top specialist. You are going to be highly skilled. You are going to be well paid, highly paid for your time and for your skills because you are persistent. So let's keep persistent. Sometimes people are afraid of, or people get bored when they have to repeat something. But I have discovered that true understanding comes from repetition. Okay, you feel like I've taken this lesson before, or you feel like I've watched this lesson before, I've watched this video before, and so you think you know it. No, you don't. By repeating, you realize that you will get the knowledge. In our bootcamp, we talked about spatial repetition. It is a technique that top professionals use to learn. Lawyers, medical doctors who study books upon books upon books, that is a technique they use to retain knowledge. All right. So there is something called spatial repetition. You can learn something today. Later on, you go back to it. After a while, you go back to it. If you keep going back to it, you realize that it will stick and you have the skill. All right. So I'm super excited. I'm very, very happy that we are making a lot of progress and we are going to look at the next topic in Python. And this topic is data manipulation with pandas. Pandas. That is very, very powerful. Very, very powerful. So pandas is a major library in Python that if you understand it, you can manipulate data in almost every way. This is a tool we use to analyze data. This is a tool we use to do machine learning and AI and everything. This is the same tool you'll be using to analyze your cybersecurity logs and do a whole lot of data manipulation. So when it comes to dealing with data, you will be using pandas. So what is important is for us to get a foundation of pandas and understand this library very well. Yes, so in the next few lessons, about 3 lessons from now, all of us will have a good grasp of pandas and we can use it to do wonderful things. If you put on your CVs that on your CV that you know pandas, it is a big plus. And in pandas, we are going to be introduced to what is called data frames and what is called series in pandas. And by the end of this lesson, you will be able to efficiently load data, filter, explore, clean, and analyze data sets using pandas, gaining hands-on experience with data frames to enhance your data handling skills in Python. Python is a powerful tool, and when it comes to handling data, we need to use the right libraries to be able to handle data really, really well. You may be having a CSV, and the CSV may be hard to manipulate and analyze and transform and clean. But then, if you learn how to use pandas to convert it into a data frame, then it becomes very flexible for you to do whatever manipulation, whatever analysis you need. So it's very important that we study this library, and it is called Pandas. If you can hear me, please type Pandas in the chat for me. Let me see who will type it first. Pandas, 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 pandas. And I have NPCU. I don't know who is called NPCU. I have Eldad, Pandas, Tesfalem, Pandas, Menja Prosper. Good to see you. Pandas, Newman, Pandas, Esimame, of course. Pandas, Marasi, David, Robley, Pandas, Israel, Rubin, and a lot of people. Yes, thank you for joining the class. Today we have a lot of people joining. I don't want you to be missing these classes because a lot is being put into it and it will give you the skills in the end. All right, we started long ago and we are still learning. So make sure you are part of it every Wednesday and you sharpen your Python skills. All right, so we are going to start with a simple question. What is pandas? And we are going to understand how it is and what pandas is used for. What pandas is used for. We will explore the basics of this library and understand how it really is so that next time when you import it into your Python project, you know that it can solve the problem you have. So pandas, and this is not panda, it is pandas. So let me see if anyone made a mistake and everyone typed pandas. I think only one person typed pansa. It's not pansa, it is pandas. Pandas. So pandas is a powerful data analysis library in Python. Pandas is a library in Python for data analysis. Yes. Just as we studied about request, which is a library for automation, Pandas is a library for data analysis. Yes, and we understand that in Python, there are third-party libraries that we can import to do wonderful things. If you want to do machine learning, there's a library to import, and you have access to a lot of machine learning tools. With this Pandas, we are able to analyze data really, really well in Python. Let's see why it is so important. Pandas is well suited for loading and reading data from various sources, including Excel, CSV, JSON, and SQL. Now, whenever you are using Python, you will need your data, and the data will come from multiple sources. Now, in Python's memory, Python can accept the data from SQL, from JSON, from CSV, from Excel, but Python finds it difficult working with that data. Python finds it difficult working with that data in these formats or from these sources. And so what Python wants to do is to load the data from these sources into a special memory where it is able to create its own matrix, its own spreadsheets of a sort, its own data structure that makes it flexible for it to manipulate it anyhow it wants. So of course, the data can come from CSV. Python will accept it, but Python doesn't want to work with the CSV. Python wants to load the data into a new environment where it is more free and has more control to work on that data. This is why Pandas is so useful and where Pandas comes in. Pandas makes it easy for the data to be split, to be merged, for you to join, to clean, and organize the data sets, making it an essential tool for data manipulation. Pandas is great for organizing, cleaning, and transforming data. So picture Pandas as a world where Python has control over, where Python has more power to organize the data really, really well in a very, very flexible manner. Python can manipulate the data, can split the data, can transform the data, can get into the data and fix any issue, can clean the data and make the data easy to work with. And so although we can receive the data from multiple sources, including a web page, we want to extract the data and store it in our own environment where we can easily manipulate. And that is Pandas. Now, Pandas provides two data structures that you need to be aware of if you are going to be working with data in Python. Pandas provides two data structures, and the first one is called series. Series. Please type series in the chat for me. Series. Series. Thank you very much. So Pandas organizes the data into two main data structures. Depending on the project, depending on the kind of data, Pandas will convert the data or will organize the data or will load the data into a series or into the more popular data frame. So when we started this lesson, I mentioned that we are going to be introduced to series and data frames. Please type data frames in the chat for me. Data frames, data frames, data frames. Thank you very much. Thank you. You guys are amazing. You can type really, really fast and you are following. So the magical world that I spoke about, that Python has the flexible control of when it comes to working with data, is the data frames. And for some kind of data, Python uses or Pandas uses the series. So when you take Pandas, you realize that the data will be organized into either a series or a data frame. So we are going to look at those two and see what they are. Once your data becomes a data frame, now Python can really work with it, which makes it easy to organize and manipulate data sets. Let's start with series. Now, in Python, a series is a single column data with an index. In Pandas, a series is a single column of data with an index. So let me just give you a picture here. Now, if the data you are working with is a single column data, or what we call a one-dimensional data. One-dimensional data. Please type that in the chat for me. One-dimensional data. Data with a single column. It is referred to, or Pandas would like to use what is called a series to store that data. So there are two environments in Pandas that data is organized into, either series or data frame. Now, if Pandas stores the data in series, every data item will be given an index. So if you look at this picture here, you are going to see the value and the index number. Now, the series can hold any data type. It can hold integers, it can hold float, it can hold strings, and it makes it easy to access. So sometimes we are working with data that is one-dimensional, and so with that, it is best to use a series in Pandas to work with it. So this powerful library that we are talking about here, we are just being told or introduced to the two data structures that it has, how it handles data. So if the kind of data we want to work with is a single column data or one-dimensional data, Pandas would like to use series. And you as a developer, you need to store it in a series. All right, if you are dealing with a single data, single column data, we'll talk more about that. Now, a series is best for handling one-dimensional labeled data. Just like the picture I showed you, it's just a one-dimensional data with a label. For example, we have time series like stock prices, temperatures. We have categories like product types, like survey responses, numbers such as sales scores, text such as names, descriptions. If the data is a one column or one dimensional data, then it is best to store it in series in Pandas. Once you have it in series, then you can easily work with it. Now, this series is like an array or a list. You see, in Python, sometimes we have a data structure called a list. And you can see that the list stores the data in series. A list is a one-dimensional data structure in Python. All right, it's a one-dimensional data structure. And so if you want to deal with data in the form of a list or an array in Pandas, then in Pandas, we don't call it an array, we don't call it a list, we call it series. So you have to convert the data into series. Series is the data structure where Pandas is able to allow Python to manipulate lists very well, or one-dimensional data really, really easily. All right. We can see that in Python, sometimes the data structure we are working with, becomes a key value pair, and it becomes multi-dimensional, and you can even nest your key value pair in a multi-dimensional way. If the data becomes multi-dimensional, then you realize that it is different from a list. A list is like a single dimensional data structure in Python. Now, Python has its own data structures to work with data, but we have a special library that is able to take data, organize it in a special way, in an easy way for Python to be able to work with it in a more powerful way. All the data structures we already know about in Python, such as lists, sets, tuples, dictionaries, they all have limitations. When it comes to dealing with large data sets, you don't need those data structures. You need a more robust and a more powerful data structure like Pandas or NumPy, which we'll be looking at later, to work with large data sets. When we talk about large data sets, we are talking about tens of thousands, hundreds of thousands of rows of data. With that, you need a powerful environment to work with. And that is where Pandas comes in. Pandas was built upon NumPy, but Pandas is very dynamic, is very popular, is very versatile to handle and work with data. We have seen the series, and this is another picture here where you can see one series or list or one array on the left, and you see a picture of the data frame on the right. We all know that if you create a list in Python, the list has positional index numbers. Is that true or false? Is that true or false? If you have a list, the lists all have index numbers. Okay, good. So just like list, we have series in Pandas. In other words, if you are bringing data like a list, in Pandas, we call it series. This new library stores it in something called series. A series is more powerful than a list. We all know how lists work, but series is an advanced type of data structure that can work with not just small data sets, but extremely large data sets. When we have multidimensional data or data in table forms with multiple columns, Pandas does not use the data structure called series. It uses another data structure to handle multidimensional data sets. What is the name given to the data structure for handling multidimensional data sets in Pandas? Who can tell me in the chat? If only you are following what I'm saying, if only you are listening to me. In Pandas, we have another data structure. It is called DataFrame. So one important thing we have learned just now is that Pandas has series and Pandas has DataFrame. Series is for one-dimensional data sets, and DataFrame is used for multi-dimensional data sets. Now, most of the time, the data sets we'll be dealing with are multi-dimensional, and so most of the time, we are going to be using data frames. A data frame is a two-dimensional or multi-dimensional table with rows and columns, where each column can have different data types. So anytime you have data with multiple columns and rows, data in the form of spreadsheets, data in the form of multiple columns in the form of a table, then we use a data frame. Let me give you the picture here. Your data in Excel is not that powerful. Your data in CSV is not that powerful. For it to be fast, for it to be able to be easily manipulated in a high-performing environment, in big data environment, in large data set environment, the data needs to be given to Pandas. Pandas is designed for that. Pandas is designed for that. Pandas is a special standalone library that has been built over decades for scientific computing, and it is very powerful. So sometimes you can give simple data sets to Pandas, but Pandas is built for single large data sets and to operate in a high speed, high performing environment. And so if you really want to manipulate your data using Python, then import Pandas and use Pandas. And of course, if the data is multidimensional, use a data frame. Data frame is the most commonly used Python data structure for working with data sets. So hardly would you hear about series, but most of the time you see DF, you see data frame. Yes. So sometimes you can even combine two series to form a data frame. But a data frame refers to a data structure or data that is in a table form. And most data, most structured data that we analyze are usually in a table form. So if you bring the data in CSV, Pandas can make it a table so that Python can easily work with it. All right. So here we have two series and we have joined it to become a data frame. All right. So now let me find out whether the concept of series and data frames are clear. Is there anyone here who understands it? The concept of series and data frames. Is there anyone here who understands it? Let me see who understands. So Newman says, I got it. Benedine says, I got it. Francis, Lucretia, great to see you. Tesfalem, Ibrahim, Lois Ominde, Robly, of course, Robly, Prosper, Norbert. Okay. All right. Okay. So that is it. So don't treat this Pandas lightly. It is a very powerful environment that can receive data and allow you to do magic with it. All right. So we are going to try some demo and we are going to practice using Pandas. In the next 3 lessons, we are going to be working with Pandas. And we want to explore it and understand it, because if you understand it, there's a lot you can really do in Python. If you really understand Pandas, you can really do a whole lot whenever it comes to working with data. So we are going to be working with a cybersecurity data analysis where we are going to analyze security logs to identify intrusions and to identify systems that are blocked and systems that are trying to penetrate into our network. And you understand that anytime there's a networking environment, we keep data, we keep records, we keep logs of the activities. So we are going to analyze it. So in cybersecurity, you do a lot of analysis as well. And this will help you to see how Pandas can be used. So this Pandas is not only used by data analysts. The concept, the knowledge, everything is the same. You just need to understand it. but it is used in cloud, it is used in cybersecurity, it's used in web development, it's used everywhere. All right, so we are going to work with a data set on GitHub. That is a cybersecurity data set, and we are going to start exploring the data set little by little. And we are going to progressively get deeper and deeper working with Pandas. So our first challenge here is to install Pandas and to import it into our environment. So you can use Jupyter Lab, you can use Jupyter Notebook, you can use Google Colab to work on this challenge. So if you have not installed Pandas, you can just go ahead and install it. Who can tell us how to install Pandas on our computers? If you have Python installed, how do you install Pandas? If you know it, please put it in the chat and we will look at it. So Francis says pip install Pandas. All right. So thank you all. Thank you all. So what we are going to do is to make sure we have Pandas on our computer, and you install Pandas, and Pandas will work if you have Python installed. So if you don't have Python installed, you can't install Pandas. You shouldn't install Pandas. So install Python first. If Python is working well, if you've already been using Python, then you can go ahead and install Pandas. So let's see how we can install Pandas. Let me share my screen well, and we'll go ahead and install Pandas. Okay, so this is my screen. We can use the terminal here, or you can use any command prompt or PowerShell to do your installation. So over here, let me zoom in a little. Sorry. Let me zoom in a little. Is my screen visible? And if you don't have it, okay, my screen is not visible. How is that possible? Let me. All right. So let me know if my screen is visible now.
Yes, it is. We are seeing your slides.
All right. All right. Thank you so much. Okay. So I want to open to my terminal. You can use command prompt. You can use PowerShell. You can even use your Jupyter Lab to do the installation. All right, so pip install Pandas. All right, so when you type pip install Pandas, this is a command that will install Pandas, the Pandas library, and it works with the Python package manager pip. This pip is installed when you have your Python properly installed. Python will install the pip for you. And so if you install your Python, you can easily install Pandas using pip. So when I hit enter, it will try installing it. And right here, Pandas will be downloaded and installed for me. All right, so over here, I'm seeing requirements already satisfied. And what does that mean? When you see that, what does it mean? Requirements already satisfied. What does it mean? Who can tell us what it means in the chat? All right. So when you see requirements already satisfied, someone is saying it is already installed. Thank you, Robley, as usual. All right. So what I'm going to do next is to get my Jupyter environment ready. And so I'm going to open to my browser, and I'm going to go back to my command prompt and type Jupyter space lab. If you are using Jupyter Notebook, you can say Jupyter space notebook. If you're using Jupyter Lab, you can say Jupyter space lab. So when you do that, it will start the server for you and you'll be able to use Jupyter Lab. Now I'm starting Jupyter Lab because I want to try doing the installation in Jupyter Lab environment. And the challenge or the exercise we are going to do, we are going to do it best in an IPy environment like Jupyter Lab. So I wouldn't want you to use PyCharm today. I want you to use Jupyter Lab today. If you don't have Jupyter Lab, you can just use Google Colab as well. So to use Google Colab, just go to colab.google and you'll have access to a Jupyter notebook in the cloud. So this is a Jupyter notebook. You can open to a new notebook. This is a Jupyter notebook hosted on Google Cloud. So it is the same notebook environment. You can work with it, or you can use the installed one on your computer like Jupyter Lab. So let me click here to create a new tab. And over here, I'll start a new notebook. So I click here and then a new notebook begins. All right. So over here, if we want to install Pandas, if we want to install Pandas, what we can do is to use the same command pip install Pandas. But because it is in Jupyter environment, you need to begin with an exclamation sign. So right here in Jupyter, you can also do your installation. So after typing this command, you can click on run and it will process it and install Pandas for you. So you can see here, requirement already satisfied. So this is how to install it. So if you don't want to install using the command prompt, you can install it right here. But if you use this environment, you need to begin with this. All right. Now that I have it installed, I'm going to delete this particular cell. And now that it is deleted, I'm going to import it. So to import Pandas, I'm writing a comment here. I believe we are all familiar with comments. Who knows how to import Pandas? Who knows how to import Pandas? We've been importing a lot of things in our previous classes. So how do we import Pandas? So challenge one is to import Pandas. All right. So almost everyone knows it. You type import and then you say Pandas. This will install Pandas, but most of the time we use an alias as PD. Now, if you use PD here, this PD is an alias. It is a nickname that you are giving to your Pandas. And so you are just telling Python to import Pandas, and after importing it, call it PD. This over here is a convention or something that's in the Python community we always do. So that if you want to call Pandas, you don't type Pandas again, you just type PD and you have Pandas. Now, this PD here is not compulsory. You can use anything you want. You can put your name there, import Pandas as Darlington. And so next time when I call Darlington, I'm actually calling Pandas because I've given Darlington as a nickname to Pandas. But it is best to follow the convention and just use PD because everyone uses PD in the Python community. And when you use PD, it will be more readable. It will be easy to recognize your code and all that. All right, so let's run it over here and we'll see the number here and we'll know that it has been imported. Now, if you don't have it installed, you can't import it. In this Jupyter environment, if you successfully run your code, you will see that if you successfully run your code, you see that the number will appear over here. Now, these boxes, like we've already been talking about, they are called cells. These cells, you can create more over here. For example, when I click on this arrow, this icon, I can create another cell. This cell, I can move it up. And once a cell is up here, I can choose to type code in it, or I can choose to type Markdown. Markdown is like text. So if you want to write text, you can select Markdown. And if you select Markdown, this cell will no longer be used for code. It will be used for text. So we can type challenge 1, and then it says importing pandas. So it's actually installing and importing pandas. So we've done that here, installing and importing pandas. So when I run it, it becomes text over here. Now this text, I can come here and I can place an asterisk in front of it and provide a space. And when I run it, it will become a heading 1 text. Heading 1 means it's very large. If I want it to be heading 2, I can use 2 hash symbols and it will become a little small. Let me try 3. All right. So in your Jupyter environment, you can input text, you can input code, and you can also see the result of your code over here. Let's move on with our slides. So over here, I put the same code we'll be using here. So if Pandas is not already installed, you can use pip install pandas to do it. And you can also import it just as we have over here. So we are just taking pandas from the very, very basics. And I know everyone knows what I'm talking about. But like we said before, repetition is good. It's good to repeat what you already know. So let's look at challenge 2. Challenge 2 is to get a data set from GitHub. So we have a repository and the data set is actually online. It's on GitHub. And so we want to see how we can bring it into Pandas. Now, this data set is a CSV data set. It's a cybersecurity data set. And it is in CSV. And just like we studied in the introduction, Python doesn't want to work with a CSV. Python wants to convert it into a data frame before it works with it. And so what we want to do is to load the data from CSV and give it to Python and allow Python to use Pandas to convert it to a data frame. And so I'm going to share the link to the data set and I'll let everyone import it. Now your data set can be on your computer, it can be in the cloud, it can be anywhere. This time we have the data sets on GitHub in the Rita Africa GitHub account. So I'm just going to open it and we will work with it. So let's open to GitHub. All right. So we can go to github.com/RitaAfrica/Rita Africa. So when you get here, I've created a repository here called data. You can click on this data and you can see that we have network traffic data here in CSV. So this data set is what we are going to use. When you click on it, you'll see that GitHub will try loading it. So this is a data set we are going to work with in Pandas. So over here, you can see the URL of the data set. And our next task is to load the data set from GitHub. So there are 2 ways we can go about it. First, we can store the URL in a variable and then call Pandas to read it, and we'll provide a URL to it and then store it in our data frame over here. Or we can place the URL directly over here. So let's go to Jupyter again, and where we are writing our code, right here, we are supposed to load the data sets from GitHub. So over here we have PD, and we know the data set is CSV. So you can type pd dot read underscore CSV, and then you open parentheses, and then you can place the URL over here. All right, let me repeat that. Now, instead of calling pandas, we can call pandas as PD because we give it an alias here as PD. And when you add a dot notation here, you'll be able to see the methods that pandas comes with. So just like the string methods we studied last week, pandas also has a lot of methods. Now, in Jupyter environments, when you type PD and you type dot, you are not going to see the methods show up until you type the method you are looking for. These are all functions or methods in pandas. But after you type the dot notation, you can press the tab key and it will reveal the methods that pandas work with. Now, last time we were talking about strings and we saw the string methods. Today, we are not talking about strings. We are talking about a powerful library, and it has a lot of methods that we can call. One of the methods you can call is to read Excel if the data is coming from Excel. Or you can read CSV if the data is coming from CSV. Or you can read HTML if the data is coming from HTML. Or you can read JSON if the data is coming from JSON. And over here, what do you see here? If my screen is visible, what do you see here? What do you see here? Someone should put this in the chat for me if my screen is visible. Okay. Now, it is a function. Last week, we learned that a function or a method is also a function, just that it belongs to a class. It belongs to a class. And then it is a child of the class and can be accessed with a dot notation. So all of these are methods that comes with pandas. And to use it, you type dots. And if you know it, you can just type it. If you don't remember, you can press tab and you can access it over here. So what have we done so far in pandas? First of all, to use pandas, you need to be able to install it and you need to be able to import it. We have done that. If you can do this, then you have the basics of pandas already on your fingertips, knowing how to install and import. The next thing is to know how to load data. So let me write another markdown here. It's just a comment and type challenge 2. Challenge 2, knowing how to load the data sets. So to load the data sets, all you have to do is to use your alias here and say read underscore HTML. And if you say read underscore HTML, what it means is that you are aware that you are going to be using or be working with HTML data, or the data set you want to load is in HTML. The data set we are working with, let's check the format again. And after checking, we can see that the data set, okay, someone has it already. The data set we are working with, who can tell me the format? What is the format of the data set? Okay, CSV. Thank you very much. Now, who knows what CSV is? What is CSV? What is CSV? What is CSV? What does it stand for? What does CSV stand for? Okay, so CSV stands for comma separated values. Thank you very much. Let me download this data, and it's going to be downloaded over here. And we can see that it is CSV. Let me open it in PyCharm, and let's see how the data looks like in PyCharm environment. So most of the time, you are going to be given raw data in CSV, and your job will be to work with it in Python. Now, over here, I'm seeing a lot of numbers, and it is even hard to analyze this or look at it. I can see that the first line has some headings with comma. I see timestamp with comma. I see source IP with comma, destination IP, comma, protocol, comma, byte, comma, a whole lot. And after that, I'm also seeing some information here separated with comma, and then comma, and then an IP address, comma, TCP, comma, NA, comma, a whole lot with comma, comma. So the data here, it is an organized data, all right, but it was organized with commas. That is why we call it a comma separated value. Now, Python doesn't want to work with comma separated value. So Python wants you to convert it into a data frame. So what we are going to do is to call our PD and say, read our CSV for us. And then we provide the CSV. Over here, you can paste the link to GitHub over here. And then you have the data given to Pandas. By typing this, you have given the data to Pandas. And you can go ahead now and store it in a data frame. Now, in Python, most of the time, we use certain naming conventions. For example, anyone working with Pandas uses PD as an alias and uses DF as a data frame most of the time. So let's run this and see if there'll be an error or it will work. Okay, so I'm seeing some errors, and we are going to find out why it is not able to read it. All right, so let's check the URL again. And by entering this URL directly from GitHub, it's able to take us to where the data is. But let's use this. Let's use this. And with this, we'll be able to have access to it. So let me enter the link in a different way. So over here, before the GitHub, you can type raw dot GitHub user content.com, then Rita Africa, then data, and then we have main, and then we have the file name. All right. Now you can choose to download it and load it from your system, or you can choose to load it directly from GitHub. Now, most of the time, we'll be working with data sets from online. And so in this particular class, we want to see how we can work with data directly from an online platform. So let's run it again and see if we'll get the errors again. And this time, you can see that it was able to load. Now, to be sure that you have the data, you can type df in another cell, your data frame, and then you run it again. And if you got it right, your data will load over here. Okay, so this is the part where you pay attention to the practical aspect of using Pandas, because we have talked about the theory and now we want to look at it practically. Now, before you use Pandas, first install and import it into your environment. And then you need to provide the data to Pandas. Now, because this is multi-dimensional data, Pandas will convert it into a data frame. This is why we created a variable. This is just a variable representing our data frame. However, by reading the data, Pandas will convert the data into a data frame. So it is not compulsory to do this. The only thing is that we want to store it somewhere. So this is the process of creating the data frame. Because we have the data from GitHub, and the data is a CSV data, and we are giving this data to Pandas. And the way to do it is to say pd.read CSV, because the data is CSV. Then the whole data frame can be stored in a variable. You can use any name to store the data frame. However, in the Python community, we like to use df to represent your data frame. If you are using a Jupyter notebook and you want to print in this environment, you don't have to type the print command like this to print. Just by typing the variable, if it contains data, it will print it. And so we don't want to use a print command or the print function. We just type df, and by typing df, we can see our data loaded here in a data frame. So what you are seeing here is called a data frame. It is no longer CSV, it is now a data frame. You can see that it also has index numbers over here. It also has the index numbers over here. So just like the picture I showed you, just like the series, yes, just like the series, you can see the index over here. And this allows us to be able to target any row that we want. All right. We've only done 2 steps, and this is a part you need to grasp. If you get lost over here, then you are going to be lost, because to work with Pandas, we need to understand the basics. All right. So I want to find out if everyone is okay or someone is lost. I want to find out if you are following. If you are following, you can put I'm following in the chat, and then we'll continue. So following, Francis is following. Thank you very much. Thank you very much. So we've only done 2 steps, And these are the 2 things you will have to do when using Pandas to be able to get a hold of what Pandas really is. Don't worry about how long this URL is. It is just the link to where our data is stored. Sometimes the data can be downloaded. And if the data is downloaded, you need to load it from your computer. You need to load it from your computer. So let me try loading it from our computer. Let me try loading it from our computer so that we see the difference. So you can either load it from your computer or load it from online, just for those who may be very, very new to it. Now, to load this from our computer, the first thing I'm going to do is to save this particular notebook. If you are working with Jupyter, you can see that you are no longer getting .py, but you are going to get .ipynb. This stands for Interactive Python Notebook. And you are going to see untitled here if your work is not titled. So let me just go ahead and let me save this notebook. And instead of untitled, we are going to call it network traffic. Let's call it network traffic data.ipynb, and we rename. So by renaming this, it will store it for us. So Luis is getting some errors. Your code seems to be all right. Okay, so remove the blob from the link and try again. Remove the blob and try again. I don't think we have blob in ours. All right. Some people are writing code. All right, that's beautiful. Okay, so I have saved this and let me check here if I can find it. So I can find it right here. I can find it right here. And because I can find it here, what I need to do is to make sure that where my data is stored is also either right here or my data is stored somewhere that I can easily locate. When I go to downloads, I'm going to see the data set over here because I downloaded it. So I just press N on my keyboard and I can see it right here. Let me copy it, or to make this very easy, let me go back to my computer and let's go to GitHub. And in our GitHub environment, here, we can click on these three dots and download it. I just downloaded it. And so if you go to downloads, if I go to downloads on my computer, I can see it right here. I can see it right here. Now I need to store it somewhere that my Jupyter notebook can find it. And so it is best to store it at the same location where your IPynb file is, where your data analysis file is. Now, to find where the data analysis file really is, I can click on this Rita Africa here, and I can check here, and I can see it over here because I know where I stored my Jupyter file. This Jupyter file, I can choose to store it anywhere, and wherever I store it, I can go ahead and paste the data set over there. So right now you can see that I have the data set here and I have the Jupyter file also here. All right. When I come back to Jupyter and I click on this right here, I can see let me go back. I can see the network traffic CSV, and I can see the notebook here as well. All right. So if I'm loading it from my computer, I can just come here and remove the URL and just do this. If I run this, if there's an error, I will know there's no error. I see the number 6. If I run this, if there's an error, I will know. So you can either load it offline or load it from online. If the data is found on drive D, you have to put D:/ over here, and it will load it from drive D. But because it is loading it from the same location, I don't have to provide any path. All right. Okay. So let's continue to the next step. And again, just by typing df, we can see a sample of the data over here. I want you to select this particular cell where the df is, and I want you to click outside it like this. When you click outside it, you can see that the cell is highlighted like this. The cell is highlighted. You can see some box around it. It is highlighted. If it is highlighted, I want you to press DD on your keyboard and tell me what happened after pressing DD. Just make sure you are not typing, but you are selecting the box from the outside. You press DD and tell me what happened. DD on your keyboard. Okay, so it deleted. Thank you. So there are some shortcuts you can use in your Jupyter environment. And today I've taught you how to use a tab to discover the methods. And we've pressed DD to delete a cell. Okay. So our data frame is still right here. The next challenge here, the next challenge we have, where's my work? The next challenge is to, okay, I didn't put a name there. We are going to perform some basic data analysis with a few methods of the data frame. And the first method we are going to use, I think you should have loaded somewhere. Okay, it's here. We are going to display the first 5 rows of our data set. So to analyze this particular data, using Pandas, there are certain methods or functions that we use to start reading our data. And so the first thing we will do here is to type df dot head. So if you type df dot head, this is a method here that will allow you to see the first 5 rows of your data. So you can type this and load the first 5 rows of your data. With the first 5 rows of your data, you are able to get an idea of how your data looks like. You'll be able to see the columns of your data frame, and you can see the first 5 rows of your data. And this helps you to get an insight into the data you are dealing with. So we know we have timestamp here, and the timestamp is made up of the date and the time. We have source IP, we have destination IP, we have protocol, we have port numbers, we have bytes sent, bytes received, status, and then threat level. So this is cybersecurity data, and we just want to see the first 5 rows. Now, when you are working with Pandas, as part of the basics, you are supposed to be able to do some basic descriptive statistics on your data, like discovering the first 5 rows, and the method is .head. Let me show the next thing we are supposed to do. This one here is to display the first 5 rows. So let me put a comment here, display the first 5 rows. Let's run it again. It's working. Next is to check the number of rows and columns we have. So we are going to use another method in the data frame. So when we type df dots, we are able to see or use what is called shape. When you type shape and you press shift enter to run, sorry, let me type shape, and you press shift enter to run, you are able to see the shape of your data. So please type df.shape like this, and then run it, and you are going to see the shape of your data. Now, what do we mean by the shape of your data? The shape of your data refers to the rows and columns you are dealing with. Sometimes when you are given a data set, you have no idea how large the data is. And so Pandas has some methods that can go into the data and tell you what you are dealing with. Right now, it's telling you that your data has 9 columns. Let's see if it is true. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8, and 9. So Pandas has been able to tell us exactly the number of columns, but then the 1,000 refers to something else that is important. The 1,000 refers to the number of rows. All right, so when you have data and you are working with that data, you need to know the number of rows you have, the number of rows you are dealing with, and this helps you to discover the number of rows. Okay, so let's continue. And we are talking about one of the most powerful libraries that allows us to work with data, manipulate data, do data analysis, do machine learning, and we are going to explore that library. The first thing we've done is to know how to install and import it and how to load data to it. Remember, if you are not loading a CSV, don't type read CSV. If you are loading Excel, we have seen that we have read Excel. You can read Excel and just provide a data set. If the data set is on your computer, just provide it here. If it is from a repository or from anywhere in the cloud, you just provide the URL and it will read it. Once you read it, Pandas does its magic and converts it into a data frame. The data frame, you can store it here. And if it becomes a data frame, then Pandas can do whatever it wants with it. Because it is a data frame, you can now manipulate it. And you can also analyze it. One of the ways to analyze your data is to ask your data to show you the first 5 rows. There could be thousands of rows, but you just want to see the first 5 rows so that you have a glimpse into the data. This allows you to see the type of columns you are dealing with and the types of rows you are dealing with as well. Over here, we don't really want to see the entire data set. We just want to have an idea of the data set. That's why we are using .head to show the first 5 rows of the data. You can use .shape like this without the parentheses to see the shape of your data. This clearly tells you that there are 1,000 rows and 9 columns. We counted the columns and it's true. Your data frame is here in this variable called df. You can look at it anytime you want. We can also type .columns. So from what I shared, we can type .columns. With .columns, let's run .columns and see what we will get. If we run .columns, df.columns, let me see if I typed it right. All right, let's skip .info. We will do the .columns again. So if you type .info like this, okay, so what is not running on my system? Maybe I'm not running something. Let me see. Let me type df. Okay, dft is not running. So let me come back here and run this cell. Run this cell. Number 1, come here and run this as well. Number 2, run this one too. Okay. Then run the .shape again. Then let's type .columns. And it worked. All right. So because I restarted my computer, I needed to import Pandas again. So it didn't know DF because Pandas wasn't showing. All right, so I think my screen is showing. Someone can see my screen, but someone sent a screenshot. So over here with .columns, we are able to get an idea of the columns over here. And this is important because sometimes you want to know the columns and you want to use it for something in particular. Let's type print around it and let's run it and see how it appears. It's still fine. Without print, df.columns also works and you have access to it. Okay. Now let's try another method called df.info with a parenthesis. When we run this, we are going to get some information about our data set. And this information is very, very important to help you get an idea of the data you are dealing with. Let's explore this. Over here under range index, how many entries do we see over here? Who can tell me the number of entries we see here? Okay, so we have 1,000 entries, and this gives you an idea of the number of entries or rows you have within your data. Now, the entries you have here are in a range starting from index 0 to index 999. So if you are to run df, you can see, let me show you another method here. You can say df.tail, and the tail will give you, I'm going to press enter and put a comment here and say the last 5 rows of your data or of the data set. So if you want to see the last 5 rows of the data set, what is a method for that? It's called the tail. Now, who can tell me the method in Pandas that we use to access the first 5 rows? The first 5 rows. The first 5 rows is .head. So we have the head and we have the tail, not shape. The head will give you the first 5, the tail will give you the last 5. So if you check here, you can see that the data ends at index 999. That is what .info is telling us. You know, once it's a data frame, Pandas can do a whole lot with the data. Pandas can analyze it in any way, and you have not even started analyzing your data. So here we see the entries here. We see the index numbers. We see the data columns. How many columns do we have in this particular data? You can tell me in the chat how many columns we have. 9. Thank you, Bernardine. It's always alert. And we already know that we have 9 because .shape told us about this. And so we know this already. Then over here, you are actually going to see the columns right here. So with .info, you are going to get a lot of information about the data. Now, sometimes when you are analyzing the data, you need to be able to understand the data you are dealing with before you even start analyzing it. Some of these methods allow you to get a lot of information about the data before you start analyzing it. So we can see all the columns here, and we are now aware, and we can now know what we are dealing with and how we are going to work with it. We have seen the tail, and the tail gave us the last 5 rows. Let's try one more for summary statistics. It's called describe. So over here, we say df.describe. And when we run this, we are going to get some descriptive statistics on. All right. Okay. All right. So right now, the data that we have, we've not done statistics yet, but .describe has been able to perform some basic statistics for us. All right. For example, when it comes to the ports in the data, you see we have a column called ports. And there are several ports, but you can see that over here, we are seeing that this data here is not available. All right. So in analyzing this data, we have seen that there are 874 port numbers in the data set. How many port numbers were we expecting? How many port numbers were we expecting? If anybody has gotten the clue, how many port numbers were we expecting? Okay, so we are expecting 1,000 port numbers. Okay, we are expecting 1,000 port numbers because the data is telling us that there are 1,000 entries. If there are 1,000 entries, then we are supposed to have 1,000 port numbers, but we have 874 port numbers. What does that tell you? Instead of 1,000, you have 874. What does that tell you? So if you are a data analyst, you know that anytime there are missing values, there are issues to deal with. So this gives you an idea that there are missing values. When we look at the byte sent, it is counting 1,000. When we look at byte received, it's also counting 1,000. So we know that there are missing values when it comes to the port. All right. Then over here, when it comes to the port, it has calculated the mean. The mean. When we say mean, what does it mean? What's the meaning of mean? What does mean mean? Okay. So it has calculated the average. You know, there are some data sets that you want to know the average number. In statistics, this is really, really important to give you an idea of the middle of the data or the average number of what you are dealing with. Let's assume we are dealing with ages in this particular class right now. There are almost 60 students here, and we have different ages. But we have the mean age. The mean age will give you an idea about the kind of students you have. All right. The mean age will give you an idea about the kind of students you are dealing with. So some may be 19 years, some may be 40 years, but the mean will be somewhere around 28, 29, 32. If you get 32, you have an idea that after looking through 1,000 students, the mean is 32. So it tells you the kind of students you have. So in statistics, we have a lot of information to derive from the mean. And then we also have the standard deviation. So the mean and the standard deviation tell you a lot. Okay, so the average student is this, and then the deviation, the standard deviation is this. Later, we may get into some statistics, but this is just for you to get some information about it. So the standard deviation, knowing the standard deviation also tells you a lot about the data. The minimum port number is 21. The 25th percentile is 22, 50th, this and that. And then the maximum is 80, 80. All right. So these are just port numbers. We are not talking about ages or anything. But if it were to be ages, you could have seen that the youngest is 21. The max is 80, 80. All right. So let's leave it there. Next time, we can get into some statistics. But this is good information to give you a lot of idea about the data you are dealing with. Okay, So let's try one or two more. And then after that, we will get into the serious parts of Pandas. One of the important parts of Pandas that you should know is how to be able to select specific columns for display. So over here, we are going to go through the 9 columns and we are going to select some specific ones to display. Let's get back here and let me delete this and delete this as well. Delete this as well. We can always look at them anytime we want. Now we know that our DF is our entire data frame. Let me run DF again. And DF is really, really huge. Okay, we have DF here. Let me delete it. But out of our DF, let me run it again. Let's say we are interested in discovering the threat levels. Okay, we are interested in the threat levels. We are interested in the threat levels. So let's come here and see how we can access that. We can say DF, use double square brackets, and we can input the heading that we want to see. Let's try it and see if it works. DF, square bracket, square bracket, and then as a string, we put in the column we want. This column is called threat level. Let's come here and put that here as a string, threat level, and let's run this here. So what I have done here, who can tell me what I have done right here? Who can tell me what I have done here? And this is one of the important things. You need to start seeing our pandas and you need to start knowing how to do when it comes to pandas. What have I done here? I entered DF and then, okay, thank you. Thank you. So I have indexed it. That's powerful. I've indexed it to be able to select a particular column. So the same way in Python, you can create an index of a list to retrieve a particular item within the list. In DataFrames, you don't necessarily have to index with a number. You can index with a column name. So by doing this, I've been able to go into the data frame and I've been able to fetch one column. Now, what I want you to do for me is to fetch only the source IP, destination IP, and the threat level. Fetch that alone for me. If you can do this, then you can do a lot with data frames. So see how I was able to select only one column. Look at how I did it. Let me show you this code of how multiple columns were selected. Look at it carefully. And now I want you to solve this challenge of displaying specifically displaying source IP, destination IP, and threat level. If you have the data set imported in your Jupyter, you should be able to do this. If you are working in Colab, you should be able to do this. So let's see anyone who can fetch those 3 columns. If you're able to do that, please capture your screen and post it in the chat for me and let me see what you have done. And I'm sure that in the next few seconds, someone will post already, and our lovely Lucretia has given us the thread level and the source IP. So I want the source IP, destination IP, and thread level. Source IP, destination IP, and thread level. Also remember, this is a string, like I said. So string can be in single quote or double quote. And now we are dealing with a data frame. So a data frame can do a whole lot. So do whatever you want and get those specific columns for us. Those specific columns for us. If you are able to do this, this means you have manipulated the data set and you have retrieved specific columns. After doing this, when you are learning data analytics and they ask you to select a column, you realize that I have done this before. I know how to do it. This is very, very important. If you are doing machine learning and you are supposed to split your data, you know how to split it because you've done it before. Everything we've done here, we can store in another variable. We can split our data. So let's see. I have a few people who are done. We have Morang has done it beautifully. We have Hillary. He has done it beautifully. That's wonderful. We have Oluwafemi. Very wonderful. And we have Ato. Of course, Ato. Very beautiful. We have Robley. Of course, Robley. That's beautiful. All right. So to data analysts, data scientists, beginners, knowing how to do these simple things are extremely important. Next time when you are taking a data analytics course and you are supposed to split data, you are supposed to extract data, extract some columns, you see that you've done it before and it becomes very easy to do. All right, thank you very much. Okay, so please remove the blob from the URL. And I think your URL, Ibrahim, I think someone should share the URL again. I think Ibrahim needs the URL. Bernardine has done it. Thank you for always leading the way. Okay. All right. Thank you all. Thank you. All right. So let me see what we can add to this. And let's try this. What we have done, we can store it in a variable, and we can print the dot head of what we've done. So I asked you to find the source IP. So let me copy source IP from here and let me place it here, comma, destination IP. Let's place destination IP here, comma. Let me run this and see if I have it right, and I have it. And we can store this. Let's store this as TL. Let's call it TL, standing for threat level. So when I run this again, it is here. I can call TL and TL will show here. Or we can just type it threat level like this to make it descriptive. Let's run it. And let's run it here. All right. So we have threat level. Let's try threat level dot head. Let me come here and type threat level dot head. Now, when I type threat level dot head over here, if you are really following what I'm doing, what happened when I type threat level dot head? You know, this time we are not dealing with the main DF. With the part of the data that we extracted, we stored it in a variable called threat level. And when I type thread level, I'll see the entire data here. It is 1,000 rows, 3 columns. But I was able to type thread level dot head. What happened? And someone says it displayed the top 5 rows of the thread level data frame. This is beautiful. This is beautiful. If you can remember this, working with data is going to be very easy for you. If you can remember this. Okay. So we'll try one last one and we'll continue next week. And we've already done this. So this is selecting and storing blocked traffic. Okay. So what we are going to do is to create another variable called blocked traffic. And what we are going to do is to find out the number of blocked traffic. Let me explain what that means. Now, if you go back to DF, you are going to see that under status, we have some traffic that are blocked and some traffic that are allowed. What we want to do is to query out the blocked traffic. Query out the blocked traffic. And I think I should just give that as homework because of time. I don't want us to overload. So that next week we'll pick it from here, but I'm giving this as assignment to you. To select and store blocked traffic. So over here, you need to write code to be able to select out of status the blocked traffic, out of status the blocked traffic, and then over here it says select key details for analysis. So out of the blocked traffic, we can also select some columns that we want out of it for analysis. We can store that in another variable, and we can find the dot head of that. Right now, your assignment is very, very simple. Your assignment is to just store the blocked traffic. This is all that I'm giving you right now. So it is for you to select and store the blocked traffic. Now, after you filter out the blocked traffic, and you can see that we are filtering the blocked traffic from, if you check, we are filtering it from DF. DF is the main data frame. After you filter out the blocked traffic, you can also, and I'm adding this to the assignment, select these columns out of the blocked traffic. Select these columns out of the blocked traffic. Or what I want is that I want blocked traffic, but I don't want all the 9 columns. I want 4 columns, which will give us the timestamp, the source IP, destination IP. Okay, let's add status. and then threat level. All right, so please don't be confused. We want to see the status. Although we know they are all blocked, we just want to see. So filter out these columns or select these columns. They should be 5. Timestamp. So please, I think someone is writing. Timestamp, source IP, destination IP, status, and then threat level. I need 5 columns. And out of the 5 columns, I want to see all the data that has status as blocked. That's all. So please do that and send it to assignments@reachafrica.org. Assignments@reachafrica.org. Okay, so I want to know if you understand the assignment because we want to wrap up for today. So if you understand the assignment, you can let me know. If not, I will go over it. And Newman says it's not clear. Okay, good. Francis understands. All right. This is assignment. Now we have our DF, okay? The DF has 1,000 rows and it also has 9 columns. Now, I want you to query out or extract some information out of the DF. The information I want out of the DF is simple. I don't want all the 1,000 rows as you see over here. I want you to extract all the blocked ports or all the blocked traffic or all the blocked connections. Okay, so this is a network or cybersecurity analysis that we are doing. And we are identifying blocked traffic and traffic that are allowed. But right now, the assignment is to filter out only the blocked. Right now, if you look at this, we can see that we have 1, 2, 3, 4, 5, 6. But we have just looked at 10 rows. Out of the 1,000 rows, how many of them are blocked? Use Pandas to find out how many are blocked. Let me see who has done it. Francis has done it. Okay, excellent. Francis has done it. So use Pandas to filter out all the blocked traffic. Now, if you're able to filter out all the blocked traffic, store it in another variable. And number 2, we don't want to get all the 9 columns in the new data frame you are going to create out of this. We want just 5. Number 1 is timestamp. Number 2, source IP. Number 3, destination IP. Number 4, status. Number 5, threat level. These are the 5 columns we want to see in the new data frame. So the question is simple. Create a new data frame that has only 5 columns. 1, 2, 3, 4, 5. And it displays only the blocked traffic. I hope it's clearer now. If it is clear now, let me know that it is clear. Okay, good. Thank you. All right. So I'm going to inspect it, please. I'm going to inspect it. So please do that and send your code together with a screenshot to assignments@reachafrica.org. So next week we will continue from here and we have some very, very serious analysis to do. You know, as beginner data analysts, these are some of the things that really, really create headaches when you are learning data analytics. But we are taking them little by little and breaking them down so that when you really have to work on a project, it will be very easy for you because you've done it before, you've seen it before, and you understand it. So this is part of a larger goal that we have, but we just want to take it from the basics for you to understand. And working with pandas, there are a lot of manipulations that we are yet to do. Because of time, we are going to end here and we'll continue next week. And we are going to do a full analysis of the network data that we have here. If you have gained anything from this class, let me know. The chat, type yes in the chat. If you learned anything today, let me see yes in the chat. Okay. Okay. Thank you so much. Thank you. Thank you. Thank you. Thank you. I'm seeing a lot of yeses. Thank you so much. And on that note, this is where we draw the curtain and we bring an end to today's class. We will continue next week, same time. Be sure to join and don't miss anything. And little by little, we'll cover everything you need to know to be a tech professional. Thank you very much. Have a wonderful evening, and I'll see you in the next class. All the best. Bye-bye.